Okay, so back to that final thought here. Sine is equal to opposite over hypotenuse. So if that's my angle, there's my opposite, there's the right angle, so that's the hypotenuse. They both have a time component that is the same, so it cancels. So sine theta is equal to velocity of sound divided by velocity of the object. Okay. Example number 4. What is the speed of a jet? So we want to know velocity of the object whose half angle is 45 degrees in meters per second. Okay. Something we're aware of, speed of sound, 343 meters per second in air. Okay, so we need to pick an equation where we have all the information except for what we're solving for. Okay. Now, if I look up here, it's not going to be the Mach number equation because I don't know what that Mach number is, and I don't know the speed of the object. But here I know the angle, I know the speed of sound, so I can solve for speed of the object. So I'm going to choose this half angle equation. Okay, so sine of theta will equal velocity of sound divided by velocity of the object. Now, please, let's rearrange this equation, but let's keep it symbolically. Let's rearrange this symbolically before we plug in our numbers, okay? So this is what we're solving for. So I'm going to multiply both sides by velocity of the object because I want to get it out of the denominator there. So I have velocity of the object multiplied by sine theta equals the velocity of sound, and I will divide by sine theta to get velocity of the object by itself because that's what I'm solving for. So what I'm left with is velocity of the object is the speed of sound divided by the sine of theta. Sine theta, that's unitless, and then velocity of sound is in meters per second, so we end with units of meters per second. Okay. So now that I have that, I'll plug in my numbers, 343 meters per second divided by sine of 45 degrees. Three significant figures, so we have 485 meters per second. Okay, so that wraps up lecture for learning targets number 2 and number 3.